Yeah, like the hands-out, we are going to model a truss with the help of SAP, and we're doing it. Uh, the thing is, the SAP is going to give you a tip. You can ignore it. Like a hands-out, there is a truss, and it is indeterminate truss if you notice, because there is one extra member. One of the diagonal member is extra, and the thing is, uh, it's very similar like that of the beam we did earlier, but there are few things that is different from the beam, and we can notice that. Now first we need to take care of units, that is, I would like to go with kilonewton and mm. As I told earlier, this C, that is degree Celsius, doesn't matter, and we need to choose the file new model. As you can see, you can go to 2D Truss, but as I suggested, it's better to go with grid only, and that is because you can model anything with the help of grid. You go to grid, the template comes the same. We go to Cartesian coordinate. Now look at, now there are two directions. The one is x, and the next is the septic. The y, what we called y direction, is a g direction. That's why the first one we have two grids, that is at a distance of, if you notice, this is in far, this is 5000 mm. Okay, that is 5 meter, and the g direction is again 2, and if you notice, this is like uh, uh, again 5000. Okay, and we don't need this y direction because we are in 2D, and you must notice that there are two directions. This is x, and the upward, the vertical direction, uh, in the SAP, in the default state, is g, but if you wish to change it, you can. I will show you. You can go to option. There is a 3D view. It is in J, right? I recommend you better get used to it, because every time you may forget to change it, and better it is to know that the vertical direction that's default in the SAP is G direction. So it's better to get used to it rather than changing it every time. So now this is a xy, so I better change it into xg. Now this is our template. Now what we need to do is, like the previous example, you can define two things. The first one is material. I would like to go with this one. Okay, I would like to add new property, and our new property is again 200 GPa. Or if it was aluminum, it would have been 70 GPa, but it is steel, and we like to go with steel. Sorry, steel, and the unit is kilonewton mm. You notice that this is 70 GPa. Sorry, 200 GPa means 200 kilonewton per mm square. This is about 200, but I would like to change it. And as I told earlier, there are many other things. We don't bother with them right now, but you may use them in future as we go on modeling some advanced structure. And that's all. We define our material, that is steel of elasticity elasticity of 200 GPa, and here it comes still. It's done. Now we need to define geometry, that is section properties, and we go with a new property. Here anything doesn't match with this, we need a what do you call, a square solid section. So we go with other, we go with section property, we change this into square, and we change this into steel. Okay, we go here, then we go into your it's same as done earlier. The default value is 500 by 500, but the thing is our area is 900 square. That gives it is 30 this is 30 this is not rectangle one, this is square, and this is our steel. Okay, now the geometry or the section properties like area properties has been defined. It's coming out small, doesn't matter. You can scale it if you want with the help of this. You can zoom it, doesn't matter. Display section property, the area is 900 square, that is fine. Other properties will come by itself, the SAP will handle that. It's okay. And be careful about unit, we are in okay. Okay, that's fine. Okay, now what we need to do is make a model, and making model we use this one, but the thing is it's very important to come here. Like unlike beam and frame, we cannot use continuous. If we make continuous, then the thing is in the node there is a movement coming out, but in a truss in generally, if it is not a welded truss, it is a pin jointed truss. This is pin. Okay, so the section is square. That is what we want. Now we can go here, here, go here, 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 and what we can do is go from here to here. This is our truss. Okay, now what we need to do is fix the node here. Here is a what we call hinge. That is, I click here, go to assign. Now I go to joint, I go to restrain, and I go to hinge. Okay, this is a hinge. I click this one, I go to assign, I go to joint load. No, I go to joint, assign, joint, that is restrain, and I go to roller. I say, okay, here comes the roller, here comes the hinge, here comes our structure. Everything is done, but we are still to put the load, and the load is here. But before putting the load, we need to define the load as a load cases. But we don't need a load cases, so I would better define load pattern. This is our okay. This is just the name of the load, so you might want to put it something interesting, like to remember this is your load pattern. Like I would like to put it like, okay, put it truss. Then this is, we are going to put a live load. The self-weight multiplier should be 0 as I explained earlier, and that's a new load pattern. That's okay, this is done. Okay, now what we can do, we can choose this node, we can go to, we need to assign, we need to go to joint load, we are giving, we need to change this into truss. Okay, the unit are very important. Since we are putting force, we may neglect this displacement unit, and the coordinate is global. In the x direction we are putting 5, that is 5, and it's kilonewton. In the y direction, that's not. In the g direction we are putting minus 10. Okay, that's all, that's all. Okay, now see, you can see the load. This is 5, this is 10. Now what you need to do is run this model like this. This is do not run, this is do not run, this is run. Okay, run now. I need to save it like trust, desktop, save. That's all. Okay, this is a deformed shape. You might want to look. This is a deformed shape, and as a like earlier, what you can see is go to this one. This is okay. So deformed shape, this is fine. Okay, so the this one is the deformed shape. Okay, this one is the deformed shape. You might want to go to here, so deformed shape. You might want to go to here, so forces, and that is just truss. Case combo. Okay, this is look at here. What this is something called a reaction. Okay, this is 15, this is 5, this is 5, and there is a 10, that is okay, and this 5 is coming out. Now what we need to do is we can go to display and show forces in frames and cable. This one we can go to axial force, and we can go to field diagram. Okay, that means this red are in compression. Okay, this red are in compression and this yellow are in tension. So if you want to look for the value, sorry, if you want to look for the value, you can go to this one frames, and what you can do is show values. Okay, now these are the values. This is 3.02, this is 3.02, this is 11.98. This member is in compression, that is 4.27. This member is in tension, that is 2.8. This member is in tension, that is 3.02. That's all. And you might want to display these if you want, like display so table. You want to go to join output. Yeah, in joint output you might want reactions only, no displacement. In the element output, what do you want? We want object and element. Okay, then it's done. Look at here. At node 1, that is this node, uh, here are two reaction. This is X, this is Y. Okay, sorry, this is X, this is G, this is X, this is G. Okay, this is G positive, this is X negative, this is G negative. Now you might want to go into this one, and sorry, okay, this is the what do you call, uh, this is something we don't want. We might see by, okay, go to display so table. This area reaction in the element output, frame output, this one. Okay, okay, this is the frame output. Look at, you don't need everything. You just first, if you want to see this, this is member 1, member 1 0 500. This is like member 1 is 5000 mm long, and it is giving the shear force at every point 0 500, that is 0.5 meter. And what I need to do is, you just need this, and if you want to see which member is which, you can go to, okay, first you might want to, okay, if you want you can export the table into Excel, and it's the Excel, and you might, this is member 1, this is member 2. Member 1 has station 0500, and everywhere it's same, and this is tension, this is compression, this is tension, like what. You can save it if you want. The thing is, if you want to see the node number, you can always go to this plane and label in joint in frame. If you want to label joint, then okay, here in this 1 2 3 4, for example, I want to do here, I want to label, okay, look, it's coming 1 2 3 4. Now if you want to do it for member, you might want to go in frame cable, label. Okay, now the member, now this is member 1, member 2, member 3, member 4, member 5, member 6, and you can do anything you want to. For example, you don't want to look at the load, then you might release it. If you want to then look at the restraint, you might release it. Okay, it is restraint, but it is not just showing. You might want to look, this is what. So this is the analysis of Truss just for the member forces. You can also find the displacement or anything else with the help of SAP. So I hope this is fun learning, and good luck.